Hey everybody, Mr. Bruss here. Today is Tuesday, September 22nd, and it's Tuesday morning, and I'm going to do a little pre-cap video. Instead of my recap, I had a little bit of time this morning, so I want to just talk about what we're going to talk about today and go through kind of my logic through some of the puzzles. So today we're going to start out with a practice quiz. It's a 10-question kind of ungraded. It's going to show up in PowerSchool, but it won't count to your grade. And the idea of this practice quiz is simply to see for you to see where you're at in your understanding. And in addition, for us as bio teachers to see if there's any consistency among the students of places where there's confusion. And then we can spend a little bit more time on that. So this is a classic formative quiz. So we're going to start the class with that. It shouldn't be a stress situation at all. It's just to see where you're at. And we have 8 days until the test for this unit. So I think there should be plenty of time to learn the concepts that you might have missed. So I think it's really important to do your best on this quiz, have done your best on this quiz. In addition, I put together, I had a practice quiz, like 70, 80 question practice quiz, and I put that into Canvas. And I just want to show where that is. And you can take that quiz as many times as you want in Canvas. And then that way you'll get used to the format of a Canvas quiz. You get immediate feedback. And also for each of the 19 questions that are going to be on the actual test, I've made 5 practice questions. So when you take the test again, you're likely to get a different set of questions. So you could probably take the test at least 5 times and get a different combination of questions. So I just want to show where that is really quick. And I'm going to hop over here to my, where is this? Oh yeah, here we go. To my iPad. And I'm going to share where this practice quiz is located from the student view. All right, so I'm going to pop over to Canvas here, load it up. And I'm going to go to my class. And again, there's a few different ways to get there. And there's my home page. I'm going to click on modules really quick. And I'm going to take a look at this. I guess I can't do it from the student view. Maybe I do that from home. I was going to try to get it from your perspective. Oh, there we go. Let's do this. Let's do the student view there. There we go. And now we'll head over to modules. And down here is this full ecology practice test, ungraded, just practice. So if you click on that, you can take this quiz. And so you pop in here and question 1, which of these choices is the original source of energy that humans receive from consuming an herbivore such as cow? So the original energy, as we all know, came from the sun. So I'd click that. And I'm not going to go through all these, but you're going to get a different set of questions each time. And so I'm just going to submit this quiz. Okay. And I should get 1 out of 13, I think. 1 attempt. I got 1 out of 4, so 14 questions, 1 out of 14, because I did get that question on the sun right. But once you're done, it will show you the question and it will show you where the correct answer is. So it's also a great study tool to understand the concept so that when you take the test again, you'll get a different question. And again, this is totally ungraded, just another way for you to practice. All right, so that's what we're going to do to start today is that practice quiz and then kind of a little review of this practice test, like what it looks like. So I'm going to pop back over to my dashboard. Go to my courses here, and then let's look at today's work. So today, after that practice test, we're really going to get to the heart. My favorite part of this unit is interpreting food webs. And that's really what we've been building for. We needed a set of language. We needed an understanding of flow of energy. And we needed an understanding of how two organisms can interact with each other, the predator-prey. And the reason we did all that is to set up what we have right now, which is the food web interdependence. This is the core of understanding an ecosystem and the core of understanding a human impact in an ecosystem. And we're going to take a look at that today. I also like this a lot because it's a logic puzzle rather than a vocabulary test. So I really love this part of the unit. And so we're going to dive into it right here. Okay, so I'm going to click on today's assignment, and let's just copy that over to Notability like we always do. My son's added a couple things onto here. So click over to Notability, and let's create a new note. It's in the right folder, so I'm going to import that over. And here we go. So what we're going to do is, this is a really short video, but very well made by the California Academy of Science, where they talk about a marine ecosystem with sea otters kind of as this keystone species. And a keystone species is really a species that outweighs its numbers are important, like are critical for like hold the ecosystem together. So they kind of outweigh every other organism in the ecosystem. So while every organism in the ecosystem is important, there are some that you can lose and the ecosystem can kind of respond in a way and mainly hold together. A keystone species, if you lose that species, the ecosystem seems to start to collapse. And in the Yellowstone National Park example, that was wolves. They happen to be the apex predator, but they're also a keystone species. An aside, in the Serengeti, in savanna in Africa, wildebeest seem to be a keystone species there, where they kind of tie that whole ecosystem together. And there's some great work on that actually by a researcher at UW-Madison, Sean Carroll, I think is his name. All right, so anyways, that's a total aside, just interesting facts to know. Here we are beginning to look at ecosystems and their dependence on each other. So we start from this video with a relatively simple question, a little bit more complex than a predator or prey, but we have three organisms now. We have the otter, the sea urchin, and kelp. And the question here is, study the graph in the video, and it's reproduced here to the right. When sea otter populations are reduced, what happens to kelp bed abundance? So let's blow this up here. We see that the sea otter is in red, and I kind of like this. This is a nice way to make the graph. You kind of make the key with the little picture in red, and then you use that color over here. I thought that was kind of cool. And what we see is the x-axis here is the year, kind of reminds us of a predator-prey graph. And along here is the abundance index. Well, that's a really fancy way of just saying the amount of that, the population. And here they're just kind of being really general, like 5 means a lot, 1 means very low. It's really, you can think of it as population. So when the population of sea otters goes down, we're asked what happens to the kelp population. Well, in this case, the kelp population goes down. When sea otter goes up, it looks like kelp kind of follows it. And when sea otter population goes down, the kelp population also goes down. So my interpretation of this graph is that when kelp population follows sea otter population. So when sea otters go down, kelp go down. And that is because sea otters like to feed on sea urchins, and sea urchins like to feed on kelp. So if sea otters keep the sea urchin population down, a lot of sea otters, sea urchin goes down. So when sea otters go up, sea urchins go down, and that allows the kelp beds to thrive. All right, so I'm gonna squeeze this down. So when sea otter populations are reduced, what happens to the kelp bed population? And let's just make this, when they're reduced, we'll keep it red actually, they go down, they are less abundant. So there we go, right there. When sea otter populations are reduced, kelp populations go down. Okay, so now later in the video, we expand out this ecosystem, this food web, from simply just sea otters, sea urchins, and kelp to many other animals, organisms in this marine ecosystem. And here's what we're looking at here. And this is a table that we're going to start looking at that I've kind of put together for you to help organize our thinking around understanding these interdependence. So what we're looking at here is we're starting off and we're saying sea otters are reduced. So their impact, they go down. So this is the organism that's directly affected. So if sea otters go down, in this case, it's the only organism that's directly affected. What I'm asking then is what happens to the other organisms that are in this food web? And that's what we're going to indicate in these boxes here. I'm going to call that the indirect impact. So because sea otters went down, what indirectly happens to these other ones? So let's look here. So if sea otters go down, then the things that sea otters feed on should go up, right? Like the sea urchins get eaten by sea otters, sea stars get eaten by sea otters, large crabs get eaten by sea otters, and large fish also get eaten by sea otters. So I would expect all of these populations to go up. So I'm gonna put this in green. So these go up. Large fish go up, sea stars go up. And it's a little confusing because larger crabs might go up, but also larger fish, the things that eat crabs, are also going up. So the effect might be a little bit smaller here, but so maybe not quite as much as the others, but maybe they'll go up. We would need to know a little bit more about the fish here, but probably all of those are going up. So now sea stars, sea urchins, large crabs, and large fish all go up. So let's come over to here. So we said sea urchins, actually looks a little ugly. Let's blow this up. So sea urchins, I'm gonna make the marker a little bit smaller. So sea urchins, we said, would go up, positive. Large fish would go up, positive. Large crabs would go up because those are the things that are eaten by sea otters. And I think sea stars too, but I can't remember exactly. Let's see here. Oh yeah, and sea stars would also go up. Sea stars are also going to go up, okay? So now, because those are all the things that get eaten by sea otters. Well, now if sea urchin population really goes up, they're gonna start munching on the food that they see down here, right? So if sea urchin population goes up, I imagine that kelp are going to go down. Microscopic plankton are going to go down. Sea stars, if they've gone up, they're invertebrates, they're going to start eating these, as well as also large crabs. So these things, these bottom of the food chain, are all going to go down because these populations of these primary consumers here, well, actually, sea urchin is only primary consumer, but these consumers are going to start eating more of these producer type organisms. And actually, invertebrates aren't producers, they're primary consumers. But these mid-level consumers here, undo that. These mid-level consumers here are going to start eating these. You can see that sea urchins go up, they're going to eat more kelp. Sea urchins go up, they're going to eat more microscopic plankton algae. Sea stars go up, they're going to eat more of these sessile invertebrates. And if large crabs are going up, they're going to eat more of these sessile invertebrates. So we think kelp, plankton, and invertebrates are all going to be going down. So kelp is going to go down. I'm going to put a negative sign there. Invertebrates are going to go down, and plankton are going to go down. Okay, so that's what we're doing today. It's just our first introduction. I'm going to close out of here. It's our first introduction to the interdependence of food webs. And tomorrow, Wednesday in class, we're going to get more practice on interpreting food webs if there's been an intervention. If something's happened, what happens across the food web. So I'm hoping we're going to have a great day in class, and I will see you all soon. All right, bye-bye.